This video is about section 2-6, which is on proving angles are congruent. In this section, we'll talk more and more about what proof is and what it means to prove something is always true. We will also, in this video, prove the vertical angles theorem and the congruent supplements theorem. But first, here's some background information that I want you to have. In geometry, we will accept postulates, definitions, and properties as always being true. And then we will use deductive reasoning to prove other statements to be true. And these other statements are called theorems. Okay, so statements that we prove to be true are theorems. Now, here's my definition of what a proof is. A proof explains why something is always true, and it uses deductive reasoning. Okay, so the format of our proof may change throughout the course of this year, as we'll start off a little more informally, and then later on in the year we'll actually go to a more formal, called a two-column proof, okay, which your textbook talks about already. But we'll start off pretty informal and explain why something is always true, and we will use deductive reasoning. So here's our very first theorem. Okay, it is the vertical angles theorem. And by the way, if it has a name, that means it's important. Okay, so this is an important theorem. And the theorem says that if two angles are vertical angles, then they will be congruent. For example, angles 1 and 3 are vertical angles, so they must be congruent. Okay, now we're going to prove this to be true because it's a theorem. Okay, so we have to ask ourselves the question of why would this be true? Okay, why is it true that angles 1 and 3 are congruent? Now, I know that you're looking at the picture and saying, well, they look to be congruent, so they must be congruent. Okay, and although they do look to be congruent, okay, this is not a postulate. We can't just assume it to be true. We'll actually prove it to be true, and in proving it, we'll show why it's true, and there's more that can be learned there and more to be understood than just assuming it's always true. Okay, now the statement I said earlier is an important one of if they're vertical angles, then they are congruent. If you can state a theorem in an if-then conditional statement, that'll give you the starting point, which we call the given. And the prove statement is the finish. Okay, so in deductive reasoning, we'll start from our given and work our way down to the prove statement using deductive reasoning and explaining why. Okay, now there are two general ways right now that I will talk about how you prove something, the format of our proof. You can do it in a paragraph, or you can do it kind of in a flow chart. Okay. And I'll start off with this one kind of in a flow chart as I'm just talking generally about why this must be true. Okay, so we'll start off with the idea that angles 1 and 3 are vertical angles. Okay, and there's a diagram for us which is very helpful. Okay, now I'm going to ask myself the question of, does that tell me anything about angles 1 and 3 besides the fact that they are vertical angles? And I don't know anything else. Okay, there's nothing else that I can tell about angles 1 and 3 besides the fact that they're vertical angles. So the next place I'll go is to the picture. Okay, from this picture, is there anything else that we can see about angles 1 and 3, or they've given us a big hint about labeling angle 2. Angle 2 is the key, okay, to this entire proof. Okay, so angle 2 is related to angles 1 and 3. Okay, how are angles 1 and 2 related? Well, they're a linear pair. Okay, and because they're a linear pair, we know something else about them. Okay, that tells us that they're supplementary. Okay, now what does it mean for angles 1 and 2 to be supplementary? That means that the measure of angle 1 plus the measure of angle 2 must be equal to 180. Okay, anything else we know from that? Well, I think that's kind of the end of that logic chain. Okay, well, let's look at angle 2 and 3. Again, angles 2 and 3 are a linear pair. Okay, they're also supplementary. Okay, and it's also true that the measure of angle 2 plus the measure of angle 3 is equal to 180. Okay, and that's again the end of that logic chain. So why are angles 1 and 3 congruent? Okay, now we have two equations, and we know quite a bit about solving equations. So I'm going to take these two equations and use them to see if I can figure out why angles 1 and 3 are always congruent. Okay, now the first thing that I'll do is notice that both equations are equal to 180. Do you see that? Okay, if they're both equal to 180, that means they're equal to each other, right? So the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Okay? Now, from this point, we'll notice that there's something in both sides of the equation. There's the measure of angle 2 in both sides of the equation. Okay, so I will use the subtraction property of equality and subtract the measure of angle 2 from both sides of the equation, and which I know is kind of weird, notation-wise, but I hope you get the idea that whatever measure of angle 2 is, I subtract it from both sides of the equation. And I get the measure of angle 1 is equal to the measure of angle 3, okay, which is exactly what we're trying to prove, that angles 1 and 3 are congruent. Okay? Now, here is our proof, our first proof, and we're proving why angles 1 and 3 must always be congruent. Now, this is not a formal proof, okay, but it is what we'll use right now as a proof, okay? So I think if you show this to, one of your classmates, to someone else, that they can see, where the deductive reasoning is and why angles 1 and 3 must always be congruent. Okay, so that's what we'll use right now, at least kind of a flowchart type of proof. And later on in this video, I'll do a paragraph proof, and those are our two basic forms of proof, informal proof right now. Okay, let's take a break from proof for a second and practice using the vertical angles theorem. Okay, we just proved that if two angles are vertical angles, then they must be congruent. So what does that mean about 5x and 150? Well, they're vertical angles, so they must be congruent. 5x is equal to 150, and I can solve this equation by dividing both sides by 5 using the division property of equality, and x is equal to 30. Okay, not too bad. In this one, again, these are vertical angles, and so they must be congruent. 7x minus 27 is equal to 4x plus 12. And then I need to solve this equation. I will get my x's together. I like to subtract the smaller one. 3x minus 27 is equal to 12. I will then get rid of the number to get the x by itself by adding 27 to both sides. 3x is equal to, let's see here, 12 plus 27 is 39. Divide both sides by 3. X is equal to 13. Okay? Vertical angles are congruent. Okay, here is our second theorem for this video, and we're proving that if two angles are supplements of the same angle, or of congruent angles, then the two angles are congruent. Okay, now what that means in this picture right here is that if angles 1 and 3 are supplements, meaning they both add to be 180, and angles 2 and 3, and angles 2 and 3 are supplements, then angles 1 and 2 must be congruent. Okay, called the congruent supplements theorem. Again, if it has a name, it means it's kind of important. Okay, so I'm going to ask the question of why is this always true? Okay, so we're given, that's our starting point. Again, this is our starting point. We're given that angles 1 and 3 are supplements, and angles 2 and 3 are supplements. And our goal is to use deductive reasoning to show why angles 2 and 3 must always be congruent. Now, I will always start with the given. What does this tell me about angles 1 and 3? Okay, I'm going to use a paragraph this time. Since angle 1 and angle 3 are supplements. What does that mean? That means the measure of angle 1 plus the measure of angle 3 is equal to 180. And I'll also say since the measure of angle 2, since angle 2 and angle 3 are supplements, the measure of angle 2 plus the measure of angle 3 is equal to 180. Okay, so good so far? So far, so good. I will then use some algebra with this equation and this equation. So, again, since they're both equal to 180, the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 3. Then by subtracting the measure of angle 3, the measure of angle 1 is equal to the measure of angle 2, and we're done. Okay, so this is using more of a paragraph proof. Again, either a paragraph proof or a flowchart proof. Either one of those is fine. Again, these are both forms of informal proof right now. Okay, here are some other theorems that we can go through and prove if we had more time, but I'll just give you the theorems for now. We could prove them later. But one is the congruent complements theorem, which is the same idea as the congruent supplements theorem, except they're with complements. The proof is almost identical to the one we just looked at. Okay, theorem 2-4, all right angles are congruent, is a pretty straightforward proof. Theorem 2-5, if two angles are congruent and supplementary, then each is a right angle. Okay, so those are some other theorems. We could prove those using deductive reasoning. So this video was about proving angles to be congruent. We talked about what a proof is, that it's explaining why something is always true using deductive reasoning. And we also proved the vertical angles theorem and the congruent supplements theorem.